Today we'll be talking about nonlinear inequalities. I'm not sure if anybody's ever talked about this with you guys before, so it will be something sort of new to you, but it's based on a lot of stuff that you've done on the other things in the past, as well as the things that we have learned this year. So here we go, nonlinear inequalities. So we're going to be solving this inequality. Notice that when I solve this inequality, there's no y's. I'm not too concerned about what happens with y's. I only care about what happens with x. So we're really only concerned about what happens on the x-axis of this graph. But it still is a parabola. And hopefully everybody knows it's a parabola. So the thing I'm going to do is I'm going to set it equal to 0, and I'm going to solve for x. So when I set it equal to 0, solve for x as it says, I'm going to subtract 1. And then I get a polynomial which I can factor. When I factor it, I can see I have two numbers. One's positive and the other one's positive. One's 5 and one's also 5. So then I'm going to create a sign chart and create an interval. So then I'm going to figure out if it's positive or negative. Remember, my goal here is to find out when it's less than 0. So in other words, negative. So here's my sign chart. So I'm going to create a sign chart, and I'm going to have a number line on my number line because, like I said, the only thing we're concerned about are the x values. So on my number line are going to be my zeros. So one 0 was 3 and the other 0 was 5. That's going to create sort of some intervals in my graph. So I'm going to pick something that is smaller than 3. So something smaller than 3 would be 2. So if I put a 2 up into my root, my x minus 5, 2 minus 5 is going to be a negative number. I really don't care if it's a negative 5 or negative 10. It doesn't matter to me. All I care about is the sign. The sign of it tells me it's negative. So I put a negative there. Then I'm going to put 2 in the other factor. When I put 2 in the other factor, I also get a negative. So I put that down there. Now I'm going to go on to another point. The other point is going to be in this interval in here. So something that's in between 3 and 5. Well, if you want to, you can pick all the fractions you want, or you could just go with the easier way and pick 4. So if I put 4 in to x minus 5, I will get a negative number. But if I put 4 into x minus 3, I will get a positive number. So that's where the values are coming from. And then, of course, now I'm going to pick a number that's bigger than 5. So a number bigger than 5 could be 6. It could be 10. It could be 100 for all it matters. It really doesn't matter. You're just going to pick a number and stick it in. So when I take a number, if I say like 6, 6 minus 5 is a positive number, so that goes there. And then 6 minus 3 is also a positive number, so that goes there. So there's my sign chart to create what happens. Now I need to kind of think about the answer to my question, because my question was, remember, when is it going to be negative? So here I have created another sign chart, and it's basically the same idea again, but remember, I'm looking at this little interval up here. A negative times a negative is positive, so I'm going to bring the positive down. A negative times a positive is a negative, so I'm going to bring that down. And a positive times a positive is a positive. So my answer to my question is, where on the graph, on the number line, is this going to be a negative number? Because I wanted to know when it's going to be smaller than 0. Well, look at that. It's going to be a smaller number in between 3 and 5. Now, in the original problem, it was less than or equal to less than or equal to 1 when we had the original problem, and then when we moved the 1 to the other side, it was 0. So that means my answer would be the interval between 3 and 5, and since it includes 3 and 5 because it was a less than or equal to, I will use the bracket instead of the parenthesis. So pretty easy. And then I can also do this based on the graph. Of course, you might not have a graphing calculator to check this way, but there's my graph, and that's the answer that we just said. If I were to look at my graph and I wanted to know where the parabola is smaller than 0, or in other words, going to be negative, it would be negative in this interval here, which again is in between the x value of 3 and the x value of 5. So we basically get the same answer by looking at the parabola, but again, we're only concerned with what happens on the x-axis. So here's another one. I have x cubed minus 22x is greater than 3x squared minus 24. So again, just like before, I'm going to make it so that it's equal to 0, or in this case, greater than 0. And then I'm going to use all of the knowledge that I have gained in solving this polynomial to find out what the zeros will be. Well, looky that. I already tell you that the zeros are going to be at -4, 1, and 6. So if I look and do my synthetic division, I would get that. So that's how I could verify that the -4 does divide evenly, the 1 goes in evenly, and then I have x minus 6. So there are my factors of that polynomial, the cubic polynomial that I have. So I'm going to use those numbers to create a sign chart. When I do that, I'm going to use my zeros of -4, +1, and +6. So obviously I would put that in a number line format with a line at -4, a line at 1, and a line at 6, which are going to divide my graph into intervals. But I can also save myself a little bit of time. So there's my intervals down at the bottom there. I can talk about the end behavior. Since this is an odd degree and it is a positive leading coefficient, I know that as it goes to negative infinity, my graph is going to go down. So that tells me it's going to go to negative. And since I know that as x goes to positive infinity, y is going to go positive infinity, that tells me it's going to go up. So that tells me it's going to be positive there. So I really don't need to substitute values into my table when I talk about the end behavior. So now I would look and see, I have my zeros. So I'm going to take my numbers, whatever number you want in between -4 and +1. I say pick 0 because it's the easiest one. And when I plug that in to the x plus 4, I get a positive number. When I plug it into x minus 1, it's negative, and x minus 6, it's also negative. Then pick a number in between 1 and 6. And I don't even remember what I used, but then if I stick it into x plus 4, it will be positive. If I stick it into x minus 1, it will be positive. And if I stick it into x minus 6, it will be negative. And then I want to do my math. I already know that this is going to be negative, so that's okay. If I do a positive times a negative, that will be a positive. A positive times a positive times a negative is a negative. And I already know that that's positive. So then my problem originally said, I wanted to know when it was going to be greater than 0. If it's greater than 0, that means it's going to be something that's positive. So that means it will be positive in between -4 and +1. And it will also be positive in between 6 and positive infinity. This time, I don't know if you remembered or not, but this time it was not an equal to, it was just a greater than. So that my answer would go between -4 and +1 and between 6 and positive infinity. Notice that I used the U there again because I'm talking about that's the answer between the two things, the two intervals. So there's basically what I just said there. And my sign chart and my inequality, not my inequalities, my intervals with my union symbol. So then what happens if I don't have something that touches the graph? So say, for instance, I get this polynomial here, and I have x squared plus 2x plus 3. I go to solve it, and I realize, oh, geez, it doesn't factor. So then I have to go and I have to solve it using quadratic formula. When I go and solve it using quadratic formula, I realize, oh, it doesn't have any real roots. Since it doesn't have any real roots, that means it never touches the x-axis. So if I'm asking for when is it going to be less than 0, well, since it never touches the x-axis, it's never going to be less than 0. So that means that there's no solution for this. It is never, this parabola is never going to be less than 0. And if you were to create your table with that, it would be the same idea. And then here's the same idea, the same parabola, except this time I want to know where is it bigger than 0? Well, it's always going to be bigger than 0 because it's never going down into the third and fourth quadrant. So that tells me that it's greater than or equal to 0 everywhere, which would mean between negative infinity and positive infinity if we're looking at the answer in interval notation, or you could say all reals. But for most of these, the answers are always written in interval notation. Here's another situation. Well, what happens if the graph only touches it once? Well, here's my polynomial, x squared plus 12x plus 36. If I were to factor that, I would get x plus 6 times x plus 6. So then my only 0 in that case is going to be at positive 6. So when I set up my interval, I would have a number that is smaller than -6 and bigger than -6. So then I would find out that when I did that, the graph is always positive, except it's going to be equal to 0 at -6. So if I look at my equation, I want to know where is it going to be just bigger than 0. Excuse me, not bigger than or equal to. So it's going to be bigger at 0 everywhere but -6. So if I write that in interval notation, it would be written like this, between negative infinity and -6 and -6 to positive infinity. Now this is the same situation, except now I want to know, when is this parabola less than or equal to 0? And I'm using the word parabola here, but I'm kind of just talking about the numbers on the x-axis. So when is it going to be less than 0 or equal to? Well, it's never going to be less than 0. The only time it's going to be equal to 0 is when it's at -6. So that means that's my only solution, when x equals -6. Now I'm left with one last thing, which is solving an inequality that's a little bit of a different format. So now I'm still left with my rational function. Actually, it's not a function, it's just a rational equation. And I'm going to have to solve it. So in order to solve it, I need to multiply each term by the common denominator. So when I multiply that by the common denominator, I'm going to multiply each term by x plus 2. So the x plus 2 would go there, the x plus 2 would go there, and the x plus 2 would go there. Those cancel out. This one's just going to be 0 over here. So I'm left with 3x plus 4 minus 3 times x plus 2. When I distribute the 3 times x plus 2, that's how I get the negative 3x minus 6. Because don't forget to distribute the negative. Then I'm going to just add like terms. When I add like terms, I'm going to be left with negative 2 over x plus 2 is greater than 0. Then I'm going to create my points where I could have a critical point, or a point where it's going to be a 0 on my graph. So I could find that by finding where the numerator equals 0 and wherever the denominator equals 0, my undefined points. Well, the numerator is never going to equal 0, so I don't have to worry about that one for this particular problem. The only time I'm going to have a number that is going to be equal to 0 is in the denominator, and that's at negative 2. So that means I'm going to create a sign chart with negative 2 being the number that I'm concerned with. And I think that's pretty much what that says there. To find out where it's going to be positive or negative, because in our problem here, we're trying to find out when it's positive since it's greater than or equal to 0. So there's my sign chart. And I'm just taking different numbers. Remember, negative 2 was the number we were concerned about, and that was the only one we had, was negative 2. So if I look, I can put in a number that is smaller than negative 2. So I could put in negative 3. And if I put in negative 3, I would have negative over a negative, which we know is positive. And if I put in a negative 1, or any number you want, again, I'd put in 0, but I happen to write a negative 1. That would be a negative over a positive, which we know is going to be, a negative. So then I'm looking at where is it going to be positive? Well, it's going to be positive here. So the interval where it's going to be positive, and I wanted it to be greater than or equal to 0. So that means it's going to go from negative infinity to to negative 2 with a bracket. Oh, sorry, it can't be a bracket, because if it were to be a bracket, then I would have I would have it be undefined. So we also do have to look and see if it's undefined. So that's not right. We want to go from negative infinity to negative 2, and it can't include negative 2 because we're looking at a graph with an undefined point. So if I look at the next page, I can see that that is where it's going to be positive. And the graph will be positive between negative infinity and negative 2. And the graph shows the same thing. So that's the idea of what we're doing with nonlinear inequalities. We will continue more of this the next time I see you in class, and we'll have another day of another lecture on it as well. So enjoy yourself, have a good time, and I'll see you next time. Bye.